Hello, welcome. We are doing 12.5 today, which is page 68. Every time I do parabolas, I kind of color code them. So if you remember this color coding at all, go ahead and pause and see if you can fill in the rest of that. I'm going to go ahead and start it. I want to know if it opens up or down. I've got to look at my A. The A right here is positive, so that tells me that it opens up. My vertex, to find the x-coordinate of the vertex, I'm going to use negative b over 2a. So that's going to be negative. Opposite of b is negative 3 over 2a, which is 1/4. So this is actually going to become positive 3 over 1/2. This is going to be 6. So my x-coordinate here is 6, which is also my axis of symmetry will be x equals 6, and that's where my middle point on my t-chart is going to be a 6. So from here I can plug in that information. I'm going to show the work right here to figure out what my y-coordinate is. So 6 squared is 36, divided by 4 will be 9. 3 times 6 will be minus 18, plus 2, I get negative 9, plus 2, I get negative 7. So my vertex is going to be at 6, negative 7. I know I'm opening up, I know I have a fraction, and I want to pick some other points here. So if I'm at 6, well actually I can start here, 0. If I plug in 0 times 0, okay, I get 2 right here. So I know that my y-intercept is going to be 0, 2. And if this is my axis of symmetry, I know that if I go 1, 2, 3, 4, 5, 6, I'm going to go 1, 2, 3, 4, 5, 6. I'll be out about here. I don't know where exactly it's off the graph, but I'll be out there somewhere. And before I go on, first going back to here, if this is 3 divided by 1/2, remember if you have two fractions and you're dividing, technically that is multiplying by the reciprocal. So you're going to keep 3 times 2. That's how we got the 6. Now right here I have 6 here. I want to pick numbers to the right, numbers to the left. If I go to the left here, I could go 5. 5 squared would be 25. I can't really divide that by 4. What if I go to 4? 4 squared is 16. Yeah, I could do this one. I could put a 4 in right here. Well, if I pick a 4 to the left, 6, 4, I want to pick an 8 over here because it's going to be symmetrical. So 4 squared is 16. 16 divided by 4 is 4. 3 times 4 is 12. Plus 2, I get 6. Minus 12, I get negative 6 here. Well, if this is negative 6, this will be negative 6. 4, negative 6 will be right here. 2 over, go 2 over, this is where 8 would be. So I know it has to be symmetrical. So if I pick 3, 3 squared will be 9, I don't want to do that. What if I pick 2? 2 squared will be 4. 2 is going to work. 2 squared is 4, divided by 4 is 1. Minus 3 times 2 is 6. Plus 2, I get 3 minus 6, I get negative 3. Well, if I pick 4, I pick 2. I'm going to go 2 more, I'll pick 10. 10 has to match 2, which means they'll both be negative 3. 2, 1, 2, 3. This is going to be 10. 3 right here. Now, the reason I did the orange right here is because if I go 2 more and I go 0, I know this will be 2, which means 2 more, this is 12, which would be 2, and I already had that point out there. So here is my parabola, And I can go ahead and move it. Really slow and precise when I'm graphing this because I'm doing as pretty as possible. Anyway, there we go. So go ahead and make sure you're practicing those on your own beforehand. We are going to talk about volume of pyramids and cones today. This is nice because it coincides with what we've been doing. You just did volume of prisms and cylinders, and the formulas are very similar, only this time we're going to do a third of them. So it's similar to what we've been doing if you want to pay attention to that. Because it meets in a cone, just like the surface area, we had to take half on cones and pyramids. We have to take a third on the volume. So find the volume of the pyramid here with the regular. We've been doing a lot of letters to the side. For volume, I need height and base. Capital B means area of the base, and I need capital V means volume of the whole shape. Well, looking at the shape of the height, and again, it doesn't have to be regular. This one's kind of oblique. The height is 5 centimeters. Well, the area of the base down here, it's a regular polygon. So if I have a regular polygon, the area for any regular polygon is 1/2 apothem perimeter. And then my volume right here is going to be 1/3 area of the base times the height. Okay, so I have 1/2 apothem perimeter. Well, this is 2, 2, 4, 6, 8, 10, 12. My perimeter is 12. I have to, hopefully I remember that when I have a regular hexagon, this from the center is going to create an equilateral triangle every single time, which means I create a 30, 60, 90 triangle right here. I'm going to go ahead and draw this triangle out to the side here. So remember that if I have a 30, 60, 90, my shorter leg is x, my hypotenuse is 2x, my longer leg is x root 3. So if the whole thing is 2, the x right here is 1, my hypotenuse would be 2, my longer leg here is 1 root 3, or just root 3. So here's my apothem. My apothem is root 3. Well, I'm not done with the base yet. I can simplify. Half of 12 is going to be 6 root 3. Area is going to be centimeters squared. So here I have enough information. I'm going to put in 1/3. Area of the base times the height. Area of the base is going to be 6 root 3 times my height, that's 5. 1/3 of 6, I'm going to get 2 root 3 times 5. I can multiply that by the front coefficient. I end up with 10 root 3. Now remember, it's a volume, so this time my units are going to be cubed. And there we go. Very, very similar problems here. If you want to go ahead and work ahead on your own, the formula is up here for the volume of a cone. This time you know that the area of the base is a circle, so pi r squared. So it's the same, it just depends on whatever the base is. Same letters here, everything's really, really similar. This one's a decimal. I personally, I don't think the decimals are necessary. We're going to take them out right now. I'm just going to make this a 10 and a 6. So let's write that out and make it a 10 and a 6. Okay, so we need to find the height. We have a right triangle here. It's Pythagorean there. You could always use the actual decimal answers and come up with that word. It's just a little bit longer. You have your calculators. You can do that. I'm going to use the integers. Here I'm going to use Pythagorean theorem, 6 squared plus 10 squared equals c squared. 100 plus, I get 136 equals c squared. That is going to be 4 times 34. I get 2 root 34 is my height. Or my slant height. Sorry, my slant height is what I'm finding right here. 2 root 34. And my units are meters. Circumference, remember, you can always put the formulas out to the side. I think it's easier if you think through to write those formulas out. My circumference is 2 pi r. My lateral area, if we remember, because it's asking me to do surface area also. We're going to do surface area first, then I'll do volume. I'm going to do both of them. Surface area down here. Oh, it asked me to do this one up here first. It doesn't really matter. You could start up here and do that. I don't know why I started down here. I'm going to do surface area first, but you can go up and do volume first if you want. If I remember, lateral area was 1/2 the circumference times the slant height. Area of the base is a circle, it's pi r squared. Surface area is the area of the base plus the lateral area, or lateral area plus base area. You only have one base here. For the volume, up here you need your height, you need your area of the base, and you need your volume. Area of the base in this case is pi r squared. So the height here is actually 10. I don't need the 2 root 34 yet. The height is going to be 10 meters. My area is going to be pi radius squared, which will be 36 pi meters squared. So my volume now, remember, is going to be 1/3 area of the base times the height. 1/3 area of the base is 36 pi times the height, which is 10. 1/3 of this is 12 times 10. I get 120 pi meters cubed. So actually starting with volume was probably a little bit easier. It was just a little bit easier work, so it's kind of nice. Down here, now for the slant height I had to use Pythagorean theorem, got the slant height. My circumference is going to be 2 pi radius, or 12 pi meters. Lateral area is going to be 1/2 my circumference times my slant height. I get 6 times 2, I get 12 pi, don't forget your pi, square root of 34 here. Area is going to be meters squared. Now my area of the base, again it's a circle, pi r squared. So my area of the base is 36 pi, which is what I used up top, so I already had that. Surface area is going to be my lateral area, which is 12 pi square root of 34 plus 36 pi, only one base, and I can't add those together because one has that root and one doesn't. So surface area is meters squared. There we go. Okay, I'm going to ask you to do this one more time over here. This time we are not asking to find the surface area because it is oblique. You could only really find the surface area when it was a right cone because it had that slant height that would be the same everywhere. Because it's oblique, your slant height is not going to be the same, so you can't use the same formula. Here, though, you can find the volume, and again, I'm just going to make this 3, so 3.1. Okay, so what letters do you need here? You are going to need your height, your area of the base, and your volume. Area of the base is a circle, pi r squared. Volume is 1/3 area of the base times the height. So again, you have to go over the letters, go over the formulas each time, write them out every time. In your homework, also make sure you're doing that, writing out every step, just so the habit of doing is going to make it an easier process for you. My height here is 7 inches. Pi radius is 3 squared. I get 9 pi inches squared. 1/3 9 pi times 7. I get 3 times 7, giving me 21 pi inches cubed because it's volume. Okay, hopefully you guys are catching on to these. They're nice. It's really repetitive to what we've been doing all of chapter 12 right now. Go ahead and flip to the next page. Go ahead and do this one. We need to work backwards now. So what do you know, and can you find that out? I always need my height, I need my area of the base, and my volume. So area of the base is pi r squared. Volume is 1/3 area of the base times the height. Well, can I work this out? I know that my volume is 1/3 area of the base, radius is x squared, I get x squared pi. Height here is 15. So 1/3 x squared pi times my height of 15. And I know that this has to be equal, then tell me the volume over here. So what's nice is I have an equation, I can just solve this up backwards, solve it. I take 1/3 of 15, I get 5 x squared pi equals 2262. So I'm going to divide by 5 pi. I'm going to get x squared equals 2262 divided by 5 pi. And if I don't have a calculator, can I work this out by hand? Without a calculator, I'm going to want to square root this. For all intents and purposes, x squared would equal the square root of this. You could rationalize your denominator and make it root 2262 times 5 pi all over 5 pi. Now, plug that into your calculator just to see what you get, kind of confirm. I get approximately 12.003 feet. Let's go ahead and check that and make sure you get it. Next two here, 4 and 5, are definitely, they're not something you're going to see a lot of. They are just problems we like to kind of show you the relationship and how they could relate to things in real world and things like that. The first one here, the base right there is a prism, and then the pyramid part of it of the light fixture. Here's a light fixture where there's a prism, like a base, that has a pyramid attached to it. Well, the base is a regular hexagon for both of those. So the area of a regular hexagon, remember, is 1/2 apothem perimeter. So this hexagon up here, each side is 8. 8 times 6 is going to be my perimeter. I need to figure out the apothem. So if I were to draw straight to the middle, right, you'd have this little triangle in the middle here. That is going to be a 30, 60, 90 every single time. So if the whole thing is 8, this part is 4. Remember, the hypotenuse would be 8. The altitude here, or the apothem, not the altitude. The apothem is going to be 4 root 3. So I get 4 root 3 here. Half of 4 root 3, I get 2 root 3 times 48. 48 times 2. I get 96 root 3 for the area for both of those bases. So for this one I have a 96 root 3. For this one I have a 96 root 3. Well, the height of the prism is 0.5 up here. I like fractions, so I'm going to write 1/2. The height of the pyramid is 6. So if I want to find the volume of the whole thing, well, the volume of the prism is going to be 1/2 area of the base, which is going to be 48 root 3. This is the volume of just the prism. The volume of the pyramid is going to be 1/3, 96 root 3, times the height of 6. So 1/3 of 6 is going to be 2 times 96. I end up with 192 square root of 3. That's 192, sorry. Now I want to find the total volume, so this is the volume of the prism, volume of the pyramid. I'm going to add those together to get a total volume of, I can add like terms here, 240 square root of 3 inches cubed. So this is definitely kind of a challenging problem and not what I'm going to ask you to do in class, but it is interesting to be able to see how you can apply it. The next one is also a little bit tricky. I'm going to pause and set it up first. The information we have, we know that it's going into the funnel at 198 milliliters per second, and it's coming out the bottom at a rate of 60 milliliters per second. So the difference in that is how much we're getting in the funnel, 138 milliliters per second. Our conversion is 1 milliliter is 1 centimeter cubed. I want to figure out the time it will take for the funnel to overflow, when it will get to its full point and then start overflowing, if that's how much it's coming in per second. So I need to figure out the volume. Well, the letters I need for volume, again, are height, area of the base, and my volume. Well, the height of this funnel over here is 9 centimeters. The area of the base, pi r squared, 8 squared, I get 64 pi. Now my volume, remember it's a cone, it's going to be 1/3 area of the base times my height. Well, 1/3 of 9 is 3 times 64 pi. I end up with a total of 192 pi milliliters. That's how much it's going to take to fill this up. So, the rate to which it's going to be, if that's the volume I need to take the volume that I have and divide it by the rate for which it is going into the funnel. So my volume is 192 pi milliliters over the rate, which is 138 milliliters per second. So go ahead and use a calculator for this. 192 pi divided by 138. Again, I would always use the pi symbol in here, and you should get approximately 4.368 seconds. Again, this is definitely a tricky one, and I just kind of walked us through it. Hopefully you always pause with ones like this and try to do them on your own. But we have to look at what was going in, what was going out, what was the rate after the difference of what was happening, the volume of the cone, and then you want the volume over the rate to get the full time of how long it would take. This down here, again, this is a review that is likely that you will see at some point on tests, on the Canvas tests, things like that. Definitely pause this and try to set it up. Remember that these set up the same each time. This up here is going to be the area of the sector over pi r squared, the whole area. This one's going to be the length over the circumference, which is 2 pi r. Remember, the degree is the same. It's 72 in each case. 72 is the part over the entire degree, which is 360. So 72 goes into 360 exactly 5 times. So these are both going to reduce to 1/5. My radius is 15. And from here I could just solve the problem. 15 squared is 225 pi. I'm going to get my area is equal to 225 pi divided by 5. Here I'm going to get 30, so I'm going to get that my length is equal to 30 pi divided by 5. This one's nice because definitely I know 30 divided by 5, I'm going to get 6 pi right here. It's circumference, so it is just units. Over here I've got to divide, I don't know this right away, 225 divided by 5, I get 45 meters squared. Oh, pi. Do not forget your pi in both cases, but I forgot it up top. So don't forget your pi, and that was it. So good luck. Hopefully you guys are doing great, and keep it up. I will see you next time.